Time is not a feeling. It is not a human invention. It is not just what clocks measure. In physics, time is a property of the universe. It is as real as length, width, and height. When you say here, you point to space. When you say now, you point to time. If you like similar educational content, please like, subscribe, and share the video with your friends. And in modern physics, those two things cannot be separated. Space and time form a single structure. It is called spacetime. No event exists without time. No motion happens outside time. No reaction, no explosion, no decay escapes it. Time orders reality. It decides what comes first and what comes later. You release a cup, then it falls, not the other way around. That order is not logic, it is physics. The most basic definition of time in physics is simple. Time is the dimension that allows change. Without time, nothing could move. Without movement, nothing could evolve. Without evolution, no stars, no chemistry, no life. For centuries, physicists believed time was absolute, that it moved at the same speed everywhere, that the universe shared one clock, that every now was universal. This was the world of classical physics, the world of Newton. In that world, time could not slow down. It could not speed up. It was a perfect background ticking forever. But experiments destroyed this idea. Time is not constant. Time is not universal. Time is not rigid. Modern physics discovered something unsettling. Time bends. It stretches. It reacts. It changes. Time depends on two things: motion and gravity. The faster you move, the slower your time flows. The stronger gravity becomes, the slower your time runs. Time does not exist independently of matter. Matter distorts time. Just like mass bends space, it also bends time. This was Einstein's revolution. He showed that space and time are not separate arenas. They are one fabric, one structure. Anything with mass deforms space-time. Stars, planets, black holes. And where space-time is distorted, time itself changes speed. Near massive objects, time slows down. Far from them, it runs faster. Not symbolically, literally. Clocks on Earth tick slower than clocks in deep space. This is not theory. It is measured fact. Satellites must adjust their clocks constantly. If they did not, navigation systems would collapse. Positions would drift. Signals would fail. Modern technology works only because time is not absolute. But gravity is not the only factor. Motion changes time too. If you travel fast enough, your time slows down. For an observer standing still, your life runs slower while you move. An astronaut traveling at extreme speed would age less than someone on Earth. Not because of science fiction, but because space-time demands it. Time is not a river everyone shares. Each observer carries their own clock. Two people can measure different durations, and both are correct. That is not opinion. That is physics. Time is not universal. Time is personal. And this leads to something deeply unsettling. The universe does not share a single now. Reality does not update itself everywhere at once. And that shattered the idea of time forever. If you could pause the entire universe and ask, what is happening everywhere right now? Physics would give a disturbing answer. That question has no meaning. There is no universal present. What is now for you is not now for someone else. This is not philosophy. It is mathematics. The reason is simple and brutal. Information takes time to travel. Light is not instant. No signal moves faster. No observer sees reality as it truly is now, only as it was. When you look at the sun, you see it as it existed several minutes ago. Distant stars appear as they were millions or billions of years in the past. This means the past still exists as information that has not yet arrived. But the deeper problem is not distance. It is speed. Light always travels at the same velocity no matter how fast you move. That single rule destroys global time. Two observers moving differently will disagree about which events happen together. What is simultaneous for one observer is not simultaneous for another. This is not illusion. It is relativity. There is no universal clock, no master timeline, no single timeline that everyone shares. The universe does not agree on now. Each observer slices reality differently. What you call present is a private construction based on your motion through spacetime. To another observer, your present may already be past. To another, your future might already be history. Time is not absolute. Time is perspective. And reality obeys physics, not human intuition. So when you ask, what is happening right now in another galaxy? Physics answers, there is no single answer. Now depends on who is asking. Time is not a shared river. It is a personal stream. And this strange rule is not rare. It applies everywhere, every moment, forever. Which means the universe is not marching in step. It is a web of overlapping realities, all valid, all real, and all incompatible. And that is just the beginning. Time does not only depend on motion, it also depends on gravity. The stronger the gravity, the slower time flows. Not because clocks break, not because mechanisms fail, but because gravity bends space-time itself. Gravity is not a pulling force in the usual sense. It is geometry. Mass reshapes the structure of the universe. Stars, planets, and black holes do not just curve space around them. They curve time as well. Where space-time is stretched, time slows down. Close to Earth, this effect is small, but real. Clocks on Earth run slightly slower than clocks in orbit. This difference must be corrected continuously. Without this adjustment, satellite navigation would drift wildly. Coordinates would fail. Synchronization would collapse. Technology on Earth works only because engineers account for gravitational time distortion. Now imagine a far stronger gravitational field, a neutron star, or worse, a black hole, a region where mass is crushed into an extreme state, where gravity becomes so intense that even light cannot escape. As you approach a black hole, gravity intensifies, and time begins to stretch. For an outside observer, an object falling toward a black hole slows down. Its motion becomes slower and slower. Then, it appears to freeze at the edge. Time seems to stop. The object never quite crosses in, not from the outside perspective, but from inside, time does not stop. For someone falling into a black hole, everything continues normally. They do not feel time slowing. They do not experience freezing. The difference is not in time itself. It is in observation. Time becomes split by perspective. Two observers watching the same event experience different realities. Both valid, both correct. Near a black hole, the difference between 1 minute for you and 1 minute for the rest of the universe can grow enormous. Time near intense gravity can slow down so much that years may pass outside while minutes pass inside. This is not fiction. This is pure consequence of space-time geometry. Gravity does not gently bend time. At extreme levels, it nearly shuts it down, which forces a terrifying question: if time can slow, can it stop? And if time stops, what does existence become? And deeper, is time something real, or just an effect of perspective? To answer that, we must go even smaller than black holes, down to the smallest possible level. When physics descends to the smallest scales, something strange happens to time. At the quantum level, reality does not behave like a clock. There is no steady ticking, no flowing stream. Instead, systems change through jumps, through probabilities, through states. A particle does not exist at a single location. It exists as a cloud of possibilities. Only observation forces an outcome. But here is the problem. Many fundamental equations in quantum physics do not contain time at all. They work forward. They work backward. They do not care about direction. This creates a shocking realization. At the deepest level, time has no arrow. Past and future are not written into the laws of nature. Then where does time come from? Not from particles. It comes from numbers. One particle behaves randomly, but billions create patterns. Those patterns make direction, and that direction is disorder. The growth of disorder is what makes time feel like it moves. A shattered glass does not reassemble, not because it is impossible, but because the chance is unimaginably small. Time emerges from probability, not from command. The universe prefers disorder. Order fades, and we interpret that as time passing. The past is a state of lower disorder. The future is a state of higher disorder. Time is why memory exists. Time is why change feels one way. But here is the deepest question. What if time does not exist at all? What if time is only a result of complexity? When systems become large enough, time appears. When systems are small enough, time disappears. Some physicists believe time is not fundamental. They argue that the universe may be timeless, and what you experience is a projection, an effect of information processing. Time could be an illusion created by the brain, not fake, but emergent, like gravity emerging from particles. Time could also emerge, and we only feel it because we are complicated. But even illusion, if shared by reality, becomes real. And now the final question remains. If time bends, if time slows, if time may not exist, can we travel through it? Once you understand that time is not rigid, a question becomes unavoidable. Can we move through time like we move through space? To the future, yes. To the past, maybe not. Time travel into the future already happens, every second. But physics means something more extreme. Can you move faster through time than the universe? And the answer is yes. Relativity allows you to arrive in the future sooner than everyone else. Not by jumping, but by slowing your own time. High speed does this. So does intense gravity. Move fast enough. Stay near a massive object. Your personal time slows. The universe outside moves faster. When you return, little time has passed for you, but years may have passed for everyone else. This is not a loophole. It is consequence. Time travel forward is not forbidden. It is engineering. Backward travel is different. General relativity allows mathematical structures where time can loop. Wormholes, closed time paths, rotating spacetime models. On paper, time could bend back into itself. But reality does not obey paper alone. Paradoxes break physics. What happens if you prevent your own birth? What happens if you change the cause of events that already happened? Physics offers three possibilities, none proven. First, the universe prohibits contradiction. Anything that would create paradox simply cannot happen. Second, timeline branching. You do not change your past. You create another. Third, the past exists but cannot be reached. No experiment has ever shown backward travel. And until quantum physics and gravity unify, nobody knows if it is possible. Time may resist being controlled. It may allow us to accelerate into the future but not return. Or time may not exist at all. We might only walk through slices of reality that already exist, every moment already laid out. And consciousness moves through them like a spotlight. Or maybe time is real, but too deep for us to touch. One thing is certain, time is not a clock. It is not a simple dimension. It is the structure of existence itself. Understanding time may mean understanding the universe, and that is why the question remains open.